To our next GCSE physics video, please make sure that you watch the first two magnetism videos to help you get a better understanding of this one. And today we're going to be talking about transformers, which unfortunately or fortunately is actually nothing to do with cars, so sorry about that. But moving on, so what exactly is a transformer? A transformer is a device that uses electromagnetic induction to change the potential difference or voltage of alternating currents. Let's think about what are the basic components of a transformer. It's made up of two coils of wire which are wrapped around an iron core. The two coils of wire, so you've got a primary coil, which is from the alternating current input, and you've got a secondary coil, which leads to the alternating current output, which leads to an external circuit. So they're wrapped around an iron core, as I said. And it's really important to note that these two primary and secondary coils are not electrically connected. So let's talk about the iron core. The iron core is easily magnetized and can carry magnetic fields from the primary coil to the secondary coil. What happens when a transformer is working? In step 1, a primary voltage drives an alternating current through the primary coil. In step 2, that current in the primary coil produces a magnetic field, and if you change the current, the magnetic field changes. And in turn, the iron core increases the strength of the magnetic field. In step 4, this changing magnetic field causes a changing potential difference in the secondary coil, and finally that produces an alternating current in the external circuit. Calculating potential differences. We can calculate potential differences because we know that the ratio of potential differences on the transformer coils, so primary to secondary, matches the ratio of the number of turns. So the number of turns on the primary coil to the number of turns on the secondary coil, which can be written as Vp over Vs, where V is the potential difference and P is primary and S is secondary, and so on, over Np over Ns. And if you rearrange that, for example, if you had to find out voltage of secondary, that's how you'd rearrange it, and then you just substitute the values that they give you in the question. It's kind of a similar thing with calculating electrical power, where P is power, V is voltage, and I is current. And we know that the potential difference across a primary coil multiplied by the current in the primary coil is equal to the same thing in the secondary coil. Again, if you rearrange, you can pause the video there and you can look at how we rearrange it and get some answers. So why do we actually care about transformers? What's their use to us? Before we go into that, we need to know that there are two types of transformers. We've got a step-up transformer, which increases the voltage, and a step-down transformer, which decreases the voltage. Again, what's the point? What's the use in that? Well, it's useful because we know that the higher the current a cable is carrying, the more that energy is going to be transferred into heat, which will be transferred to the surroundings and basically be a waste. So step-up transformers increase the voltage, which in turn decreases the current in the transmission cables, which stops that waste of energy being transferred. We then use step-down transformers to make it safer for distribution. So, for example, the ones that are being sent to your homes or to factories. And that's all for today. Thank you very much for watching.